Hey grade 12s and welcome, and in this video we'll be looking at past examination questions on circle theorem. So we've done circle theorem together. We've looked at the properties of circles and angles in circles. We've looked at cyclic quadrilaterals and so much. But in this video we'll concentrate more on past examination questions and how we can answer and work out such problems that are presented in our examinations, in our final examinations. So we'll look at both GCE papers and we'll also look at grade 12 ordinary level examination questions. So let's get into solving circle theorem questions. So here's the first question that we have, and this is from 2014 paper 2. And it says in the diagram below, TR, where's TR? TR is diameter of the circle with center O. The center is there. And QR and PS are parallel. So where's QR? QR and PS are parallel. Angle TOS is equal to 80 degrees. TOS is equal to 80 degrees. And we have angle TRP being equal to 10 degrees. TRP 10 degrees. And we are asked to say find angle RPS. RPS. Then the second one says find angle PST, where is PST. And lastly, we are asked to find angle PSO. So PSO. So circle theorem is quite easy and quite interesting. So let's see how best we can apply what we have learned so far on circle theorem into solving and actually working around circle theorem questions presented to us in final examinations, in mock examinations, and in other types of exams. So there are two ways in which you can tackle questions. The first way is you finding all the angles, as many angles as you can in that figure that you've been given. So that means you finding angle PQR, you find angle PST, all the angles that you can. And the second method that you can do it is by just concentrating more on the angles that you're asked to find. So I don't know what you believe would be easier for you and what would work for you, but just bear in mind to say your examinations are timed, and so you need to know how to work around time. So if you're going for the approach of finding all the angles in that figure, then you have to be really fast. And if you are going with the approach of just mainly focusing on the angles you're asked to find, then you need to be really careful so as to not make mistakes. So let's get into solving. So we are asked to firstly find angle RPS. R, where is P? P is there. And then we've got S. And then we're also asked to find angle PST. And we're asked to find angle PSO. So what approach should we use? Well, let's have a mixture of both. Let's see what we can do. But let's start with finding angles that are easy to find. So we've been given angle TOS as 80 degrees. This angle here as 80 degrees. And if you remember, we said when you have a triangle or a triangle in a circle, and that triangle is coming from the center of the circle, in this case coming from point O, coming down to touching a chord there. The angles at the chord are the same, and these angles in that triangle, meaning angle TOS plus angle OST plus angle STO, should add up to 180 because it's a triangle, and all angles in a triangle add up to 180 degrees. So if this is 80 degrees, meaning we can find the angle that's there, which is angle OTS, and we can also find this whole angle here, which is angle OST. So if this is 80 degrees, it means these two angles plus this angle should give us 180. And these two angles are the same. So this is 2 times twice one angle. So we can simply say angle O, let's say, let me write it in a way that we can all understand. So we're going to say angle TOS plus angle OST plus angle STO should all add up to 180 degrees, because that is a triangle that we have, and angles in a triangle add up to 180 degrees. But we know that these two angles are the same. Angle OTS and angle OST are the same. So we can say TOS plus OST plus STO equals 180 degrees. So now when we look at this, we say the angles there are the same. So angle OST and angle OTS are the same. So, but angle OTS, maybe let me write it the way I've written it there, but angle STO is equal to angle OST. So meaning we can replace either one of these with the other and would have TOS plus, let's say OST plus, so STO can be replaced with OST and we'll have OST is equal to 180 degrees. So we've got TOS plus 2OST is equal to 180 degrees. But you know what our angle TOS is? TOS is equal to 80 degrees. So we've got 80 degrees plus 2OST is equal to 180. And we have 2OST equal to 180. This goes to the other side and we have minus 80. And we have 2OST being equal to 100 degrees. And we divide both sides by 2 and the other side by 2. We have OST being equal to 50 degrees. So we've got 50 there. Let me use a different color. So we've got 50 there, and we've got 50 there. 50 degrees, 50 degrees. Then what else can we find? What else can we calculate? What else can we find? So we've got that, and if this is 80 degrees and this is a straight line, it means we can find what angle is on this other side of the 80 degrees. So if this is a straight line, it means this straight line adds up to 180 degrees. So 180 minus this 80 degrees that's there gives us the angle that's remaining there. And 180 minus 80 gives us 100. So we've got 100 degrees at that point. What else can we find? We're supposed to be using blue for the angle. So we've got 100 degrees. We've got 100 degrees there. What else can we find? Well, remember that property that says if two angles are coming from the same point and they are both touching the circumference of the circle, no matter where the angles are, those two angles that you have are the same, they are equal. So can we identify any angle that is coming from the same point as another angle? Well, we've got the 10 degrees there, and this 10 degrees at PRT is coming from point P and point T. You see that? We've got PRT. which other angle is coming from point P and T? We've got PST. So if PRT is equal to 10 degrees, it means PST as well, which is just there, is equal to 10 degrees. So we've got a 10 degrees here as well. Got a 10 degrees there. And what other angle can we find? We've got a 10 degrees there, we've got 100 degrees there. This angle is at the center. Same principle applies as we had just applied in the previous parts. So if this is 80 degrees, this is 50, this is 50, gives us 100, this is 180. So if this is 100 degrees, it means this should be equal to that, and this plus that should give us 180. So 180 minus 100 gives us 50 degrees. This gives us 80 degrees. But then there are two angles, so this 80 degrees is shared between these two angles. So we've got each angle being equal to 40 degrees. So we've got this angle here and this angle here, and they are both equal to 40 degrees. So we've got a 40 degrees there, and so do we have a 40 degrees there. Okay, what else can we find? Okay, let's look at the questions that we've been asked. We've been asked to find RPS. RPS, so we are yet to find that one. And how do we find RPS? Well, when you look at RPS, RPS is coming from the same points as ROS. And one of the principles that we had talked about is that when you have an angle coming from the same point, an angle being at the circumference, coming from the same point as an angle being at the center of the circle, the angle at the circumference is simply half the angle at the center, or the angle at the center is twice the angle at the circumference. So meaning this angle, we've seen this RPS coming from the same point as ROS, and this one is at the center whilst that one is at the circumference. We can simply say this angle at the circumference is half the angle at the center. And what angle do we have at the center? We have 100. So 100 divided by 2 gives us 50. So meaning we've got a 50 at the top there. So we've got 50 degrees here. Do you understand how we've gotten the 50? If you haven't, understood, let me just go through that again. One of the principles that we had talked about, one of the properties that we had talked about when we were learning circle theorem is that an angle at the circumference of the circle coming from the same point as an angle at the center of the circle. So in this case, we've got this point and that point, and an angle at the circumference. You've seen the angle at the circumference coming from the same point as an angle at the center. Seen the angle at the center. The angle at the circumference is half the angle at the center. So if this is 100, that's 50. If this is 50, this is 100. Okay? So we found angle RPS to be 50 degrees. We go to angle PST, where is PST. We've already found our angle PST to be 10 degrees. And angle PSO. Well, PSO can easily be found. We've got a 50 degrees from TS to OS. So if this is 50 degrees and we've got a 10 degrees there, it means that the remaining angle there is simply a 40 degrees. So meaning angle PSO is equal to 40 degrees. And that is how we work around circle theorem. So let's look at a different question and let's see how it can also be manipulated and worked upon to give us the solutions. Well, this question is from the 2016 paper, and this is paper 2. And the question says, in the diagram below, ABDG is a circle with center O. Given that, so we can see ABDG G. This is a circle with the center at O there. And we're told to say, given that angle GBD is equal to 21 degrees, BC, and CE are tangent to the circle at B and D respectively. Calculate angle GOD, and also calculate GFE, and GED, and BCD. So similarly, we are going to try and look for the easy angles to find, and after that we'll come back to the questions and see if we have found most of them. So this is the center of the circle, and we've got a chord there, and we've got two lines coming from the center of the circle going and touching the chord, and these are forming a triangle. And we said if you have two angles being formed at a chord, and these two angles are coming from the center of the circle, these two angles are the same. So if this is 21 degrees, it means this one here as well is 21 degrees. So we've got 21 degrees there as well. So you've got 21 degrees there. And let me just indicate the 21. So we've got 21 degrees. These are 21 degrees. And therefore, we can find the angle that's here. We can find the angle here. And how do we find that angle? We say 21 degrees plus 21 degrees plus this angle here should give us 180. So 21 degrees plus 21 degrees plus angle DOB should be equal to 180 degrees. So 21 plus 21 gives us 42, plus DOB should be equal to 180 degrees. So DOB is equal to 180 minus 42. These are degrees. So DOB is therefore equal to 180 minus 42 gives us 138 degrees. So meaning the angle that's there is 138. So we've got 138. 138 degrees there. 138 degrees. Then what else can we find? What else can we find? If this is 138 degrees, whenever you have a cross like that, an X, crossing of two lines, the angle that's here is the same as the angle that's directly opposite it. And the angle that's there is the same as the angle, let me just extend that line, is the same as the angle that's directly opposite that angle. So similarly, if we have 138 there, it means we have a 138 here as well. Is 138. This is 138. 138 degrees there. So we have 138 degrees there. And if this is 138 degrees, this is a straight line. Can you see a straight line? BF, BG, BGF. Here's a straight line, and we've got 138 degrees there. So meaning the angle that's remaining on this side is simply 180 minus 138, which gives us 180 minus 138 gives us 42. So meaning we've got angle 42 here, and we've got angle 42 here as well, since it's directly opposite the angle 42 there on top. So we've got 42 there, and we've got 42 down there. What else can we find? Well, if this is 21 degrees, and angle BDA is 21 degrees. Do we have any other angle that's coming from B and A? BDA, we've got BGA. You see that? They are both coming from B and A. So if this is 21, it means this one as well is 21 degrees. And similarly, DBG, we've got DAG, so meaning this one is also 21 degrees. Okay? So we've got 21 there. We've got a 21 there, 21 degrees, and we've got another 21 there, 21 degrees. So we have done most of it. And then looking at this angle that we have at this point, we've got 21, and then this is a straight line, and line AE, do you see line AE? Line AE is a straight line, and it should add up to 180 degrees. So if we've got 180 degrees, it means that this angle that's from E up to line B should be 180 minus 21 degrees. So this angle here is simply 180 minus 21. So 180 minus 21 gives us 79. Sorry, gives us 59. 180 minus 21 gives us 59. So we've got 59 degrees there. Gives us 59, so we've got 59 degrees. We've got 59 degrees. And what else can we find? If we've been told to say these two are tangents, CD is a tangent and CB is a tangent. And if they are tangents and we've got a line coming from the center of the circle touching the tangent, it means this line is known as the normal. So this OD is a normal to CE, and similarly OB is a normal to CB. And the angle between a normal and a tangent is always 90 degrees. So from here, from this normal up to the tangent there, this should be 90 degrees. So let me just do that. This is 90 degrees. And from the normal OD up to line CE, this is also 90 degrees. This is 90 degrees. So we can calculate the angle that's remaining from line DB to line CB. And similarly from line DB to line CD. How do we do that? This is 90 degrees. We simply say 90 minus 21. And on this side, we say 90 minus 21 as well to give us the remaining angle here. So 90 minus 21 gives us 69. So we write our 69 there. Write our 69 there. And here we also have 69 degrees. So having found 69 degrees, we can find the angle that is up there, the angle at C. Why? Because this is a triangle that we have, and angles in a triangle add up to 180 degrees. So we've got triangle CDB. Do you see that? So 69 plus 69 plus angle C should give us 180. So 69 plus 69, these are degrees, plus angle C should be equal to 180 degrees. So 69 plus 69 gives us 138. So 138 plus C is equal to 180 degrees. C is therefore equal to 180 minus 138. And 180 minus 138 gives us 42. So meaning we've got a 42 degrees at C. So we've got 42 there as well, 42 degrees. Then apart from that, what else can we find? If this is 90 degrees, it means that this other part is 90 degrees as well, because it's a straight line. So 90 degrees there, meaning 90 degrees there. So we've got 90 degrees. And then we've got a triangle there, triangle A, D, E. Do you see that? Triangle A, D, E. And at A, we've got 21 degrees. Let me just make some room here. Yes, so I'm saying at A, we've got 21 degrees. At D, we've got 90 degrees. And we can find the angle at E. So we can say this plus that should give us 180 degrees. So we're going to say 90 plus the angle there is 21 plus the angle AED should be equal to 180 degrees. Do you see that triangle that I'm talking about though? Put A, D, E. You see that? So 90 plus 21 gives us 111 degrees plus AED is equal to 180 degrees. So AED is equal to 180 minus 111 degrees. And then this gives us 69 degrees. So we've got 69 degrees at angle AED. Where is AED? AED. So we've got 69 there. So let me just indicate the angle. So we found most of the angles. And let's look at the answers, the questions that we've been asked to find. We've been asked to find angle GOD. Have we found GOD? GOD, yes, we have. And that is equal to 42 degrees. We've also been asked to find GFE. GFE, we haven't found GFE. Okay, let's skip it. We'll come to it later. GED, where's GED? GED, we found 69 degrees there. And lastly, BCD. BCD is 42 degrees. So we are only remaining with one, and that is GFE. So GFE. When you look at GFE, GFE can be said to be equal to OFD. And OFD gives us a triangle. Do you see that triangle? Forget about this line, line AE, and concentrate on that triangle OFD. That's triangle. And for this triangle, we've got For this triangle, we've got 90 degrees there, and we've got 42 degrees, and we're looking for that angle there. We're looking for this angle there. So we've got that, that, and that. So these three should add up to 180 degrees. So 90 plus 42 plus, that is OFD, should add up to 180 degrees. So 90 plus 42 gives us a 132 degrees plus OFD is equal to 180 degrees. So OFD is therefore equal to 180 minus 132. OFD therefore is equal to 180 minus 132 gives us a 48. So OFD there is 48 degrees. So we've got 48 degrees. So therefore we've got 48. Okay, let me write it outside. .48 degrees. And if OFD is equal to 48 degrees, it means it's the same as GFE. So we've got 48 degrees as the last one that we were looking for, which is GFE, so 48 degrees. And that is how we go about solving this problem on circle theorem. So let's look at a different question now. So we are in 2016 and this is paper 1. And these are questions that you should expect in paper 1. The question says, in the diagram below, PR is the diameter of a circle with center O. Q and S are points on the circumference. The tangent to the circle at the point P meets QS produced at T. PQS is equal to 26, while QPR is equal to 42. So we are taught to say PQS is equal to 26, while QPR is equal to 42 degrees. We are asked to say calculate PRS, and we are also asked to say PRQ. We are also asked to find PTQ. So for the past questions, we've been going through the long process of finding all the angles that we might find easy to find. But let's try going straight to the angles that we need for this one. So let's start with PRS. We are asked to find PRS. What is angle PRS grade 12s? You can pause the video and try to work it out. PRS. Well, when we look at it, PRS is being produced from the same points as angle PQS. You see that? So meaning the angle at the circumference is the same as the angle at the circumference right there. So if this is 26, meaning this is also 26 degrees, and we can indicate that there. So you have PRS equal to 26 degrees. Don't know, I've written 21, it's supposed to be 26 degrees. Then the next question says PRQ. PRQ. Can you find PRQ? Well, going straight to the angles that you've been asked to find can be quite tricky because you really have to concentrate and try to look for clues and the best way of finding that angle. That's why you'd mostly be encouraged to find all the angles that you can. But let's try to dwell really on PRQ. How do you find PRQ? PRQ. How do you find PRQ? So when you look at this angle, PRQ, this angle is a part of a triangle PRQ. Can you see the triangle PRQ? Forget about this line SQ and just try to see the triangle. The triangle is PRQ. We've got this, got that, got that. This is P, this is R, and this is Q. And we have a 42 degrees there. We have a 42 degrees there. And since this line is a diameter, we said a triangle formed at the circumference with one part of it being a diameter of a circle. We say this angle at the circumference is always 90 degrees. So meaning this angle here is 90 degrees. This angle here is 90 degrees. It's 90 degrees. And if we have 90 degrees there and we have a 26 there, we can find the remaining part of it. And actually, we don't even have to find the remaining part of it. Since we're looking for PRQ, we are going straight to finding PRQ. So we've got a triangle with 90 degrees. And then we've got 42 degrees, and we're asked to find this angle there. So how do we find that angle? Angles in a triangle add up to 180 degrees. So we've got 42 plus 90 degrees plus PRQ, and this should be equal to 180 degrees. So 42 plus 90 gives us 132 degrees plus PRQ. This should be equal to 180 degrees. So PRQ is equal to 180 minus 132, and this is equal to 48 degrees. So this angle here is 48 degrees. So we found PRQ to be 48 degrees. So you've seen that even just you concentrating on the angles that you're asked, you can find, you can be able to solve circle theorem questions, but that just requires you to have a deeper insight, and it just requires you to be a bit more concentrated and focus on what you're doing compared to you finding all the angles first. So the last one is PTQ. Where is angle PTQ? PTQ is this angle there. How do we find that angle there? We're looking for this angle. How do we find this angle, grade 7s? We've been taught to say TP is a tangent, and if it's a tangent and this line is coming from the center, it means the angle between the tangent and this normal is 90 degrees. So we've got a 90 degrees there. Then we are asked to look for this angle. Can we find the angle that's here? Yes, we can. So we've got 26, we've got 42, and we can find this angle here, which will help us in turn find the angle there. So let me just do that and help you see what I'm talking about. So we've got that, then we've got that, then we've got that, and this is produced to T. And we've got 42 there, and then we've got 26 there. So we can find the angle there because this is a triangle. So these angles should give us 180 degrees. So we're going to say 42 degrees plus 26 degrees plus, let's name this angle as angle X, plus X is equal to 180 degrees. So 42 plus 26 gives us 68 degrees plus X is equal to 180 degrees. So X is therefore equal to 180 degrees minus 68 degrees. So X is equal to, what is 180 minus 68? And that is 112 degrees. So meaning the angle that we have here is 112 degrees. And if this is 112, this is a straight line, we can find the angle there. If this is 112, this is a straight line, we can find the angle that is just remaining there. And that angle is simply 112 minus 180 minus 112, which will give us 68. So we've got 68 degrees there. And therefore, PTQ then gets really, really easy to find, because all you have to do is to see the triangle this point and T, with that triangle. So let me just put that triangle there now. And we've agreed to say this is 90 degrees. We've got 68 degrees there. And therefore we can find that angle there. So to find that angle, we'll say 90 plus 68 plus, let's call it angle T, should be equal to 180 degrees. 90 plus 68 gives us 158 plus T is equal to 180 degrees. So angle T is therefore equal to 180 degrees minus 158 degrees. And therefore angle T is equal to 180 minus 58 gives us 22. So we've got 22 degrees. So for angle T, we have 22 degrees. So PTQ is equal to 22 degrees. And that is how we go about such questions. This was a paper 1 question, and you need to expect such type of questions. And if you don't want to go through finding angles that are necessary, you can go direct to those angles that you've been asked. Though this one requires you to be really, really concentrated and focused on what you're doing. Otherwise, you won't be able to see how best you can find those angles. So if you're comfortable with this, you can use this method. If you're not, then stick to finding all the angles that you can and then just putting them in the answer space that you've been given. Okay, so let's look at a different question on circle theorem. This is from the 2017, and this is also paper 1. And the problem says, in the diagram below, points A, B, C, and D are on a circle. BD is the diameter of the circle. ACB is 42 degrees. CAD is 33 degrees, and the lines AC and BD intersect at X. So we are told to say A, B, C, D are on a circle, and BD is the diameter of the circle. ACB is 42 degrees. CAD is 33 degrees, and the lines AC and BD intersect at X. So we are not told to say, be very careful there, we are not told to say X is the center of the circle. We are just told to say it's a point of intersection of the two lines. So whichever method you feel like using, you can go straight to finding these angles that you've been asked, or you can find all the angles that you can in this diagram. So you've been asked to find angle CBD. You're asked to find angle ACD, and lastly you're asked to find angle AXB. So you can pause the video and give it a try as you prepare for your grade 12 final examinations. So we can continue. So I don't know what you prefer using, but I'm going to keep things simple and I'll go straight to the point. So we've been asked to find CBD. CBD. What is angle CBD? Just by looking, believe you can be able to tell. Well, angle CBD is coming from the same point as angle CAD. They're both coming from D and C. CAD, CBD. So meaning these two angles are equal. So if that is 33 degrees, it means that this is also 33 degrees. So CBD is equal to 33 degrees. ACD. How do we find angle ACD? ACD. Going straight to the point. What do you think, grade 12s? Well, we've been taught to say the key is in the question, we've been taught to say BD is the diameter. Line BD is the diameter. And if line BD is a diameter, it means we have a triangle in a semicircle. And if that's a diameter, it means the angle here, let's use red, means that the angle here is 90 degrees. The angle at the circumference is 90 degrees. So if this is 90 degrees, it means ACD is simply 90 minus the 42 that's there. So 90 minus 42 gives us 90 minus 42 gives us 48. 48 degrees. So therefore, this angle that we have here is 48 degrees. Do you see how simple this is? 48 degrees. Why? Because this is a diameter, and if we have a diameter passes through the center of the circle, so we have a triangle being formed from the center of, with a line passing through the center of the circle and touching the circumference, and therefore this angle at the circumference is 90 degrees. So these two should add up to 90 degrees. So 90 minus this one will give us that one. So 48 degrees. So ACD is therefore equal to 48 degrees. And the last one is AXB. 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 How do we find angle AXB? So going straight to the point. Think grade 12s. Think. Well, we've got CXB, and we've been asked to find AXB. But do you notice that AXB and BXC are on a straight line, are forming a straight line? So therefore the angle here, let's use red, the angle here plus the angle this side should add up to 180 degrees. Why? Because it's a straight line. So what is the angle that's there? To find this angle, we can simply say 33 plus that gives us the angle there. And to find the angle that's there, we'll simply subtract this angle from 180. So to find this angle here, we'll say 180 degrees minus 33 plus 42. So I've done this because I believe at this point we know what's going on. So I've skipped a lot of explanations because I understand that you have understood what is happening up to this point. So we add these two, then subtract them from 180 degrees. So we have 180 minus 33 plus 42 gives us 33 plus 42 gives us 75, right? So 180 minus 75 gives us 105. So we've got 105 there. And to find the angle that's there, we simply say 180 minus 105, which gives us 75. So we've got 75 at angle AXB. So therefore AXB is equal to 75 degrees. Okay, grade 12s. So here's the last question that we are doing in this video, and this is from the 2020 GCE paper 1. So expect a lot of expect circle theorem in your paper 1s, and maybe just in your paper 2s, but paper 1 you definitely are going to have circle theorem. And so let's look at this question from 2020 GCE paper. The question says, in the diagram below, A, B, C, and D lie on the circumference of the circle, center O. And so we've got A, B, C, D, circle A, B, C, D. And we're told to say these are points on the circle. The center of the circle is at O. And we're given that BAD is equal to 47 degrees. So BAD is 47 degrees. 47 degrees right there. And DBC is 28 degrees. We are asked to say calculate BOD, OBD, and BDC. So let's get straight to the point. We've been asked to find BOD. How do we find BOD? You can pause the video and give it a try. So BOD, well, BOD is an angle at the center of the circle. And we have another angle coming from the same points B and D, that is at the circumference. So we agreed to say the angle at the circumference is half the angle at the center of the circle, coming from the same points. So if this is 47, it means this is twice 47. So 47 times 2 gives us 14 there, 8, 9. So we've got 94 degrees angle at BOD. So this is 94 degrees. BOD is therefore equal to 94 degrees. Then OBD. OBD. Well, we can see the triangle ODB. Do you see that triangle? OBD. And if this is 94 degrees, we agreed to say angles at the chord or at the circumference of the circle coming from the center of the circle are equal. So this and this, let's assume this is X and this is X. So angle X and angle X are the same. And this is a triangle, so 94 plus X should give us 180 degrees. So 94 plus X should be equal to 180 degrees. So 2x equals 180 minus 94, right? So 2x equals 180 minus 94 gives us 86. So we've got 86 degrees divided by 2, x is therefore equal to 43 degrees. So meaning we've got 43 degrees there, we've got 43 degrees there. So let's write that as our answer. So x is equal to 43 degrees, OBD. So we've got 43 degrees. And the last one is BDC. BDC. You can pause the video and give BDC a try. Well, to find BDC, remember the concept on cyclic quadrilaterals. We said when you're dealing with cyclic quadrilaterals, angles opposite each other should add up to 180 degrees. So do you see any cyclic quadrilateral? Yes. Got A, D, C, B, A. Do you see that? This is a shape with 4 sides. We've got side AB, side AD, side DC, and side CB. So this angle is opposite that angle there, right? Right? And this angle there is opposite that angle there. And we've been asked to find angle BDC. So you can find this angle firstly. And once we find this angle, we have a triangle BDC. Do you see that triangle? And we can use the principle of angles in a triangle to find this angle at BDC. Okay, so let's start with finding this angle. Well, this angle is an angle in a cyclic quadrilateral opposite the 47 degree angle. So we say 180 minus 47 degrees should give us the angle at the bottom there. So 180 minus 47 gives us 133 degrees. So we've got a 133 at the bottom there. 133 degrees, and now we've got a triangle. Okay, we've got a triangle that's something like this. And we've got 133 there, and we've got 28 degrees there. So we can find the angle there by saying 180 minus 133 plus 28. This should give us, let's call it angle D. So 133 plus 28 gives us 133 plus 28 gives us a 151, a 161 actually. So we've got 180 minus 161. Am I right? 8 plus 3 is 156, yes, which is equal to angle D. So 180 minus 161 gives us 180 minus 61. 180 minus 161 gives us 7, 10, 9, 19. So we've got a 19 degree angle there. So meaning angle BDC is therefore equal to 19 degrees. And that is how we go about questions on circle theorem. So try to look for more questions and go through those questions. And thank you very much for watching this video. Can't wait to see you in the next videos. Can't wait to interact with you in the next videos, and have a lovely day. So I hope and I believe you've understood more on circle theorem, and I wish you all the best even as you prepare for your grade 12 final examinations. Thank you very much, and goodbye.